We're going to talk about graphing rational functions, and we're going to go through some steps. And so the first step that we're going to be doing is finding horizontal asymptotes, and horizontal asymptotes are related to the degree of the numerator, the top, and the bottom, the denominator. The second thing that we're going to do really is we're going to find the domain. And the domain, we're going to be trying to find those excluded values. And in the domain, we are going to be talking about our wholes and our vertical asymptotes. Wholes are going to be removable, and they make the numerator and the denominator equal to 0. So that means a factor is found in the top and the bottom, right? You can write that down, factor, top and bottom. No, let's say factor is on. Same factor on top and bottom. Okay, but a vertical asymptote, it's when it's non-removable, right? And it's only on the bottom, only in the denominator, only on the bottom. Okay, so after that, we're going to do our normal things, which is that we are going to find an x-intercept. Now, x-intercepts are things that make x values that make the top 0. X values where the top is equal to 0. And then we do y-intercepts. Sorry, I have my wrist brace on, so that's why it looks so messy. But this is going to be the y. Well, let's just put it a little bit different way. This is when we substitute 0 in for x and we find the y. So this is the y-intercept, okay? And then we'll just kind of sketch the graph. Some of you can use tables. So let's start with this guy. So the first thing we're going to do in this guy is we're going to say, okay, well, what's the degree of the top? So the degree of the top is 1. And the degree of the bottom, the highest exponent, is 2. So the top is less than the bottom. So when the top is less than the bottom, we look up here and we see that means our horizontal asymptote is y equals 0. Now, we may pass the horizontal asymptote. This is just a guide for the end behavior, okay? We can cross this one. The things we can't cross are the vertical asymptotes, right? And so to find the vertical asymptotes in the wholes and the domain, we really start with the domain. So we look to see how, when we factor this, what does this look like? And so we will have y equals, x plus 3 on the top, and then x minus 3, x minus 1. So we just factored it. Now, that means that x is not allowed to be 3 and x is not allowed to be 1 because that would make the denominator 0. So our domain would be all the x such that x is not allowed to be 3 and x is not allowed to be 1. Okay, well, that's great. But now we have to decide if 3 and 1 are going to make a whole or a vertical asymptote. So if you look right here, let's put this, you can see that x plus 3 is the only thing on the top, but we don't have an x plus 3 on the bottom. So this means there are no wholes. And that the vertical asymptote, the other two values are vertical asymptotes, because those factors are only on the bottom. So let's go ahead and put the vertical asymptotes out. So we're at 1 and 3. Okay. All right, so next we said we were, oh, by the way, I'm going to tell you guys, don't worry about the range. So no matter what they're asking, don't worry about the range, because we are only sketching these. We are not actually perfectly graphing these, okay? So the next thing that we're going to look at is the x-intercepts. And so we already talked about how the x-intercepts make the top 0. So the top equal to 0. So we look just at the top and we find out when is x plus 3 equal to 0. Well, that's going to be subtract 3 when x is equal to negative 3. So that means at negative 3, it will make a 0. So now we're going to be at 1, 2, 3. Now you can see this is one of those places where it is going to cross the x-axis, and it's going to cross the x-axis at negative 3, okay? But when it gets past the x-axis, if it's going this way, it's still going to stay really close. Or if it's getting past the x-axis this way, it's still going to stay very close. So, you know, it's fine that it crosses, but it doesn't go very far, right? It doesn't go very far. Okay, so let's put that negative 3 back on there. Okay, so that's the only time that it crosses, which means if we're looking at these 3 sections, in this section, it can cross. But in this section, it can't cross. So either it's up on the top or it's on the bottom. And in this section, it cannot cross. So it's either on the top or it's on the bottom, okay? So this is very important when we're graphing, okay? All right, so let's go find our next thing, which is our y-intercept. So we're going to put a 0 in for x. So y is equal to 0 plus 3, and then 0 minus 3, and then 0 minus 1. So this is going to be 3, and then negative 3 times negative 1. So this is just going to be 1. So our y-intercept is going to be put a 0 in, and you'll get a 1 out. So that's going to be right here. Now, right now, I can graph the first section because I know that it's going to be getting close to this, hitting here, and then coming really close to that. So that's what I know. And I know because the only other way for it to go, if it's at this point, is to go down here. But you guys, it's not allowed to cross again, right? It's not allowed to cross again. So right now, I know that this is happening. Okay? Now, you guys are going to be allowed to make a table, and you know, so we can make a table and put values in, right? We can try more values in this area if you really want to, but you're probably going to want to try some values in this area because you might not know if, like, what is going on. Is it on the top or on the bottom? Right now, though, when we look at the factor that makes both of these, you can see that this factor only happens once and this factor only happens once. So you can see that both of the factors that make these asymptotes only happen once. Well, 1 is an odd number. So this is odd and this is odd. And the reason why that's important is because if we have asymptotes, no matter where they are, and we have one side of the asymptote is up here and it's odd, then the other one will be down here, right? But if we have our 2 asymptotes and this is even and one of them is up here, then the other one will be right next to it, like twins, okay? But because this is odd, we know that the middle section is going to be down below, but let's say we are not sure exactly where that middle section is, so we can try a value in that area, and one of the values in that area is 2. So we can substitute 2 in, and we would get 2 plus 3 over 2 minus 3, and then 2 minus 1. So we would get 5 over negative 1 times 1. So this is going to be a negative 5. So 2 goes in, and a negative 5 comes out. So in that middle section here, I'm going to erase these. 2 goes in and a negative 5. 1, 2, 3, 4, 5 comes out. Well, we know it's not crossing the blue line, the horizontal asymptote again. So we are going to go, or the x-axis, so we know that they're both down here. Now this makes sense because, as we said, this asymptote is odd. And if this one's up on the left, it has to be down on the right, okay? And it's going to turn around and come back down because it's not going to cross this. Okay, now we can also say that if this is also odd and this one's down, the next one has to be up, so it would be up here. Now, if you want to try a value, you can also try a value. So you can put in, like, let's say 4. So let's put 4 in. 4 plus 3, 4 minus 3, 4 minus 1. So we'll get 7 on the top, and then we'll get 1 times 3 on the bottom. So we'll get 7/3. Well, that's a really fun number to graph, but really it's only a little bit more than 2, right? So at 4, we're going to be a little bit more than 2, which is about right there. So you can see that that's exactly what's going to happen. It's going to stay up here because remember, you guys, it does not cross that blue line again. Okay, so hopefully that helps with that one. Let's take our same ideas and move down to the next one. Okay, so let's move this up a little bit though, because I'm not a fan of how close it is. We'll move it right there. All right, so we're gonna look at this guy, and we're gonna first look for horizontal asymptote. So we're gonna look at the degree of the top and the bottom. So the degree of the top is 2, and the degree of the bottom is 1, and the top is greater than the bottom. So we have no vertical asymptote. No horizontal asymptotes. So that means we have a possible oblique, but we're not gonna talk about that one yet. Okay. So the next thing we're going to do is we're going to concentrate on the domain and our excluded values. So let's go factor this. So the top, so we have y equals, oh, I picked the wrong one, huh? Y equals, and then we're going to have x minus 4, x plus 1. And then on the bottom we have x minus 4. Now, we see that the only thing that makes the bottom 0 is positive 4. So the domain is all the x, but we can't use 4. And it's really important that you look for that domain before you simplify, because when you simplify, you can see that there is something that is on the top and the bottom, and that is going to make a hole, right? But once I do that, there's nothing else left on the bottom, so there's no vertical asymptotes. And our hole will be made with the 4, but we're not sure what the y value would be of our hole, so we're going to substitute it in. And the only thing we have left is x plus 1. So we go y equals 4 plus 1, so we get 5. So at 4, 5, we have a hole. Okay, now we don't have any vertical asymptotes and we don't have any horizontal asymptotes, so now let's go get our x-intercept. So the x-intercept is what would make the top 0. Well, obviously we only have one more thing on the top, so what would make x plus 1 equal to 0? And that would be subtracting 1, we would get x equals -1. So when -1 would come in, a 0 would come out. So there's your vertical asymptote. And then our y-intercept is we have y equals, we're going to put a 0 in for x, and we'll just get 1 out. And so when we put a 0 in, a 1 will come out. And so that's right here. And we kind of already knew that. And by the way, we're not doing range, right? We kind of already knew that because this is y equals mx plus b, right? That's all we have left is y equals x plus 1. So our y-intercept was 1, and our slope is up 1 over 1. So we can use our slope to graph the rest of the function. And we got to pick up for that point of discontinuity, and that's removable because we're going to keep going in the same way our graph was going. We're not going to go and you do an end behavior right there. Okay, so one backup thing that I want to talk about is when it says possible oblique. Horizontal asymptotes go like this, and oblique asymptotes can go like this or go like this. They're just have any slope besides 0 or undefined. Okay. But we're not going to be talking about those until we can get the rest of this fixed up. And I'm going to move this up a little bit. And I'm going to move this up a little bit, just so that you guys don't have to have this in the next problem. Okay, let's look at the next thing. So our horizontal asymptotes, we're going to look at factored form, right? So if I was multiplying this all out, this x to the 1 times this x to the 1 would give me, my top degree would be 2, because x times x would give me x squared. Same with the bottom. My bottom degree would be 2. So that means my top degree is equal to my bottom, which means I'm going to do my y is going to be equal to my leading coefficient. Well, my leading coefficient is 1 times 1, which would be 1 on the top, and 1 times 1, which would be 1 on the top. So this is really just y equals 1. And so what we're going to do, I'm going to erase this just so that we don't have this gobbledygook. So we are going to say that y equals 1. So there's my horizontal asymptote. But remember, we can cross this, right? We're not going to find out if we cross this really, but we're going to just like help guide our graph. The harder problems are when our horizontal asymptote isn't at 0, because we're not looking at positive and negative. Okay, so now we're going to do our domain, right? And our domain is what makes the denominator not equal to 0. So we're going to be able to use any x such that this guy would be making a -2 would make that 0, and a +2. And as we look at these, no factors are the same. So these are all things that we have to look at. So let's actually write. So we have x such that x is not allowed to be equal to -2, and x is not allowed to be equal to 2. Remember, we're not going to talk about range. So why do you have that in your notes? Well, I want to have that in my notes so that you know if it's in any of your homework that you're not going to worry about that right now. Okay, so vertical asymptotes are things that are only on the bottom, and holes are things that are on the top and the bottom. There's nothing that's on the top, no factor that is on the top and the bottom. So our vertical asymptote is going to be x equals -2, and we have another one at x equals 2. Now, they both have degree 1, which means they're both odd. So we're going to really pay attention to that. So we're going to be at -2 and 2. So, and they're both odd, just to remember that, because that will be helpful later. Okay, our x-intercept is what makes the top 0. Now the top is only x plus 4 and x minus 3. So if we're looking at what makes the top 0, we know a -4 would make a 0, and a 3 would make a 0. So a -4, so at -4 we would be here, and at 3 we would be here. So right here. So as you can see, both of those are below the blue line, okay? So if I was graphing this, I would start by pretty much drawing these in, but I wouldn't know if it goes above the blue line or not. And that's not really like life or death, because even if it does go up the blue line, it's going to be going really close to the blue line at the end of the day. Okay? Now let's talk about the y-intercept. So the y-intercept is what happens when you put a 0 in for x. So 0 plus 4, 0 minus 3, 0 plus 2, 0 minus 2. And so this is going to be 4 times -3, and then 2 times -2. So we will get -12 over -4, which will just be 3. So if I put a 0 in for x, I'll get a 3 out. So 1, 2, 3. So here's the deal. Right now, because this guy's odd and this guy's odd and they're both down low, I'm going to assume that this is happening. Okay, I'm going to assume that this is happening. But let's say you didn't want to assume and you wanted to plug some values in. So you could plug as many values in as you want. So you could plug a -1 in, right? You could plug a 1 in. You can substitute a, 4 in, and just see what's going on. Okay, so let's go substitute those in. So we have -1, so -1 plus 4, -1, minus 3 over -1 plus 2, -1 minus 2. So this is going to be 3 times -4 over 1 times -3. So this and this will be a negative, so this will be a positive 4. So at -1, we will be at a positive 4, which is really close to what we just had. And then let's do another one. Let's put a 1 in. So 1 plus 4, 1 minus 3, 1 plus 2, 1 minus 2. So we're going to get 5 times -2 over 3 times -1. So we're definitely going to have a positive, and we're going to have a positive 10 over 3, which is a little bit more than 3. So it'd be like somewhere right here. So we are very close. But even just having those points, you can see that it's going back up on both sides of that purple dot. Okay. So we can say 10/3, which is not that important. Okay. Now what we can do is we can plug a point in over on the other side, and so we can go 4 plus 4. We're just substituting a 4 in. 4 minus 3. 4 plus 2. 4 minus 2. And so we would get 8 times 1 on the top, and we would get 6 times 2 on the bottom. So this guy would be 4, 2, 3. So this would be about 2/3, right? So this would be about 2/3. And if you looked at where 2/3 would be, it's about right there. So you can see we were right on track. All right. Well, I hope that this helps you guys. I know that this kind of can be more overwhelming, but for the most part, you guys are going to be matching the graph with its equation. So you're going to have to look for all these holes, vertical asymptotes in our graph, x-intercepts, y-intercepts, and make sure we can identify them. Okay, have a wonderful day, you guys.